where this quadratic line meets this linear equation. So find the solution, or find the points where the curve x squared minus 2x minus 3 meets the line minus 3x plus 5. Now, it's either the curve does not touch the line, which means that you would have gotten, or you would have, which means you would have got some some complex solutions here. Imagine if this happens to be minus 33. That means that you don't have real roots. So that will tell you that the line does not actually touch the curve. Or you could have got an answer where d is actually 0, which means that the line touches the curve once. Or you could have got a real solution like we have just done, which shows that the line touches the curve twice, which is common, you know, like if this is a curve and I draw a straight line, it's going to touch it twice, won't it? So yeah, and it may not touch it if the line is below the minimum point as well. So yeah, that's just the way they could ask the question, rather than tell you to say solve a simultaneous equation. No, they might just tell you find the point where this quadratic equation meets this linear equation. Okay, same thing. All right, now let me say that, oh yeah, that reminds me, there is another way they could coin the question. You know, examiners like to twist questions to separate prepared students from students who are not prepared. Do you realize that in the process of equating these two equations, we got another quadratic equation, which is this. And we simply found the roots of this equation. What you could be asked to do in the exam as well, rather than tell you to look for the solution to this simultaneous equation, they would just tell you to solve this equation first, as if it were just any other problem. And from that, you'll be told to plot the graph or sketch the graph. Because when you know the roots and you know where it crosses the y-intercept and you know the minimum point, of course you can sketch a graph. But when you've done that, the next question will be, hence or otherwise, find the roots of this equation. And then you'll be like, hence or otherwise, why can't I just be told to find this as a different question? Well, why am I to, how does the solution to this problem help me to find the answer to this equation? Mind you, they will not have given you this linear equation here. You just have, you've plotted this graph and you're told to hence or otherwise, using your graph, find the roots of this equation. All you need to do is think about what linear equation, what line relates this quadratic, which you already have plotted on your graph sheet, to this new quadratic you're told to look for. The roots will simply be wherever that line meets the one you already, meets the quadratic equation curve you already have. So they're not expecting you to plot a new graph and check where it crosses the x-axis. But you are to look for a line which is easier to draw, because once you know 2 points on a line, you can draw a straight line. And wherever it crosses your earlier quadratic curve is the solution to that. The only way to know the line is to subtract this from this or this from that. Either way, and you get the answer. Simple. We'll see that when we start looking at practical questions and all that, which will not be in a long time. I mean, in 2 weeks or so, we should do that. Finally, on simultaneous equation, you've got this that says xy equals to 2 and y equals to 2x plus 3. Solve for x and y. Well, you can make y the subject again. So rewrite equation 1 as y equals to 2 over x.